So let's, again, start with the derivatives, and then we'll look at the integrals. So derivative of inverse cosine has a negative. Derivative of inverse sine is exactly the same thing, except it doesn't have a negative. And then the derivative of inverse tangent, again, they're all 1 over. They all have a u squared and a 1. Tangent is 1 plus u squared, and it doesn't have the square root. So you have to memorize those 3. I don't know how else to say it. So put those on a flashcard or post-it note them to your bathroom mirror. I don't know what you need to do, but you've got to memorize those. And then today we'll be going backwards. So we'll be looking at these answers and going backwards to cosine, sine, tangent. But because sine and cosine are only off by a negative sign, you don't ever have to worry about inverse cosine, because all you would do is stick a negative out front. So going backwards, we'll never, I mean, unless you want to get creative, but we'll never have inverse cosine as an answer to an antiderivative problem, because we would just put the negative out front and say, oh, that's inverse sine. So there's only 2 rules we have to know going backwards. Now they're a little bit, they don't look exactly like the derivative rules, because people have done algebra on them and fixed them, and so we have to be able to sort of unfix them. So these don't really look like, or they look like the derivative rules, but there's these a's in there. So you have to learn how to see that this, used to be a 1, but now it's an a, and that shows up as an a over here in the denominator. Same thing with tangent. There's an a squared, there's an a in the bottom. Tangent, though, has a 1 over a out front. You got to know those. Whatever it takes to know those. That's the main new stuff for this unit, really. So the big issue on these is it's a bunch of u substitution problems. Can you figure out what u is to make everything work? But once you get the I guess u squared is really what you're trying to find, because if you can pick off u squared, a squared is just a constant, so you can always make that work. It's just figuring out what u is so that u squared is down there and du is in the top. All right, let's work some together. That'll be the easiest way to figure these out. So number 1, I guess the first job is to, which format does it look like? Before we get into u's and a's, does it look like a sine problem or a tangent problem? Sine, because there's a square root there. So I'm pretty sure it's inverse sine. And so I want to make it match. In fact, some people will put a squared minus u squared right under there, and that really helps you figure out who's a and who's u. Well, a would need to be 1, and u would need to be x. Du would be dx. And then it all matches up. Then we're good. Then we have du over square root of a squared minus u squared. And like you guys said from the beginning, it's an inverse sine problem. So inverse sine, u over a, x over 1, and always the plus c. Yeah, the over 1 is a little bit extraneous. That's not necessary, but it helps us remember to put u over a. All right, number 2. So big picture, does that look like an inverse sine or an inverse tangent to start with? Inverse sine, because there's a square root and it's minus. So I'm pretty sure this is inverse sine. So I'm going to try to start matching things up. Inverse sine has a squared minus u squared. So who's a? Or what would a need to be? 2. What would u be? X. And then du is just dx. So here's another one that was a pretty straightforward one to make things match up for a and u. So inverse sine of u over a, x over 2, plus c. What's number 3 look like? Inverse tangent. So a squared plus u squared. Now some of these, if it's really obvious who u and a are, kind of like with u substitution, sometimes people don't write out everything. But since we're still just kind of learning, I'll write it out. But this would be one where you could definitely get by without showing the work. So sure enough, we made it match exactly that inverse tangent rule. So inverse tangent, again, the big difference is there's a 1 over a out front. Inverse tangent of u over a plus c. And again, all of those 1's out front, completely unnecessary, but it's a reminder that we want to match the formula, match the pattern. All right, number 4. Now things get a little bit interesting here. Which one does it look like to start with? Okay, it looks like sine. How'd you know that? There's square root. Anything else? I mean, square root's a good enough answer. The other one doesn't have a square root. It's a minus, so that's fitting the pattern. So let's try to fit a squared and u squared on here. Okay, so things are going to be a little bit different on this one. If a squared is 5, then what's a equal to? Square root of 5. Right, not too bad there. If u squared is 2x squared, then what was u equal to? Not 2x. Maybe we back up. U squared equals 2x squared. So we square root both sides. So square root of 2 times x. Which means that du, what's du going to be then? Well, the derivative of x is 1, but the square root of 2 is going along for the ride there. So now we've got some, this one doesn't match up perfectly. I made the bottom work, like we forced the bottom to work. So the bottom is a squared minus u squared, we're good there. But this top, what do I need to do to fix this? We've done this kind of fix before. Put a square root of 2 in there, which is fine as long as we put a 1 over square root of 2 out the front. Okay, so we forced the denominator to work because we got to pick a and u. And then the numerator we had to fudge a little bit, but we can always fix by a constant and be okay. So my answer, we said this was inverse sine. So 1 over root 2, that's just from what we had to put out front. And then inverse sine of u over a, root 2 x over root 5. And yes, if we were not in calculus, we would need to clean up that square root stuff, but we don't mind that square root stuff, so we're good. Do be careful when you're writing your answer. Right? Is the x under the square root? Well, it's not supposed to be. So, that's clear. That's a little bit not clear. Like, is the x under there or not? And obviously, if you definitely put it under there, that would be wrong. So make sure it's clear who's under the square root and who's not. All right, number 5. What's number 5 look like? Okay, it looks like sine. Yeah, so it can't be. I don't think it can be inverse sine because you're right, especially compared to number 4, because there's an x in the top. So, and I can't fix an x, right? That's not. I'll just put the x out front. You can't do that. It only works with numbers. So I don't think this is going to work to say this is a sine or an arc sine, inverse sine, because we just did this problem, except now there's an x in there. So this is not inverse sine or inverse tangent. This is a different u substitution problem. So think back. What would be a good value of u so that du would show up? Because if u is 5 minus 2x squared, that takes care of the whole denominator. That's good. And then du is 3 more people you have to pick on, so 4 more. Dia, what's du? Negative 4x dx. So is that good news or bad news for this problem? That's good news because we have an x in the top, so we like that. The negative 4 is an easy fix. So this is not an inverse sine, inverse tangent problem. This is just an old-fashioned. We learned it a couple weeks ago. Du, negative 1/4 out front. Antiderivative. I'm a little short on space, so I'm going to rewrite that as u to the negative 1/2. Are you okay with that? Because it was a square root of u in the denominator. And we can't use the power rule unless there's a power. So now this really is good old-fashioned power rule. So Emily with the frowny, angry face. How do I handle, don't worry about the 1/4, how do I handle u to the negative 1/2?
The power rule, so if you add 1.
Okay.
And then it's divided.
Okay, so what do I get when I add 1?
Positive 1/2.
Okay.
And it's 0 over 5. Or, 2.
And then it's divided by 1/2,
Which
which is multiplied by 2, and then we still have this negative 1/4 out front. Yeah, you could leave that, but surely we can reduce and then put u back in there. So 5 minus 2x squared all to the 1/2, and don't forget the plus c. So that was kind of a tricky one because our brains were thinking inverse sine, inverse tangent, looked for the patterns, and this one sort of looks like the pattern, but there was an x in there that messed up the pattern. So this is where things get tricky when we start mixing things in, like number 6. Any ideas on u and du? What's that? it looks a little bit like inverse tangent because that's a nice a squared. U then would be e to the x over 2, and then du would not match the top. So I don't think inverse tangent is going to work because the derivative doesn't work. So good thought. Didn't work, but good idea. Any other ideas for what u could be so that du shows up? Because if u is 9 plus e to the x, what's du? And that's great, because that's what we have. So no fixing necessary. What's the antiderivative of du over u? Warm-ups from earlier. It looks a little bit like that, and if we did backwards from that, it would be natural log of u. So natural log of 9 plus e to the x plus c. Okay, 7 and 8 are really similar, so I'm not going to do both of them because they both involve the same basic step. Let's do, I'm trying to see which one I think would be easier or harder. Let's do 7. So it looks a little bit like inverse sine in the denominator, but it would only be inverse sine if that x wasn't there, right? So if it was just the 2, then we'd be set up for an inverse sine problem. But that x is there. In fact, if it was just the x, if we went the other way, if we ignored the 2, or if the 2 wasn't there, then we could let u be 4 minus x squared, and du would be 2x, and we'd be on our way. So that's sort of the motivation for, well, why don't we just kind of unadd this fraction and split it up? That's one of those weird things is like, why would you ever do that? Usually we want to combine fractions. Why are we breaking this up? Well, we're breaking this up because now this one looks like inverse sine with an a squared and a u squared. And this one looks like a u substitution problem where u is 4 minus x squared. In fact, why don't you take a few minutes and see if you can finish those sort of 2 separate problems. So just work them separately, and then your answer will have 2 pieces. The first piece and the second piece will have an inverse sine in it. All right, if you're following along at home, there's the first part of the problem and the start of the second part. I'm going to pause again. So the big thing that people forget is one of the sine or tangent, one of them has a 1 over a out front, one of them doesn't. And tangent is the one that has the extra a in it. So I don't need a 1 over 2 out front. This 2 that's out there is just the 2 that was there from the beginning. So that's not really part of the antiderivative process. That's just the 2 that's been there from the get-go. And then yes, plus c, but only 1 plus c because c represents anything, so I don't need to put a bunch of extra plus c's on the end. We're going to skip 8, but it would be the same method. You would split it up. And the first part would be a a u du thing, and the second part would be an inverse tangent. But you can't handle them together, you have to have them split up. Number 9, I do want to do, or at least start. Anybody remember? We've said before how to handle this type of problem. If the top degree is bigger than the bottom degree, you have to do an algebra step first. Do you remember what that algebra step is? Top no, bottom O equal co. It's not that, but it's more like top O no. Because we have to long divide. I mean, well, sometimes we can synthetic divide, but this one we're going to have to long divide. We have to divide one way or the other. So x cubed divided by x squared plus 1. And you may remember this from Algebra 2 days. Like if you're missing those terms, it might be helpful to put them in as zeros to keep things lined up. So what times x squared gets me to x cubed? X. So x cubed plus x. And then we subtract those. The x cubes cancel. That's always going to happen. We rig that to happen. That's why we picked x up here, to make that happen. And we have negative x. Now, this was a quick divide problem because there's nothing that I can do times x squared to get me to x. So what do I do with this leftover remainder piece? Yep, it goes over what we were dividing by. And now, let's see, the first part's easy. That's x squared over 2. Second part, looking at just the denominator, it looks like inverse tangent, but there's an x in the top. So I think this is a u substitution problem. Yeah, because then du is 2x. Go from there. We'll stop there. So you have to be careful because on the back, the assignment's back, not all of those are inverse sines or inverse. Most of them are, though. I guess I should be careful on that. Most of the ones on the back are inverse sines and tangents, and well, that's the only ones we have. How about some hints before the bell rings, real quick? On number 4. Let u be t squared. On number 6, let u be inverse sine of x. And on number 7, let u be cosine of x. Just put those where you can see them. So tomorrow we'll answer a bunch of those. We'll do a bunch of review questions. I'll talk a little bit about what's on the test. And then we'll test on block day.